Okay, so week 1, day 1 of network security. So the first part of the course, we're using the connecting networks coursework. So when you look in the materials in the security course, if you look at the timeline, it will give you the first 3 weeks are connecting networks material. So we have a good start on chapter 1. We'll finish chapter 1 on Thursday and probably do most of chapter 2 on Thursday. Chapters 3 and 4 next week, and then chapters 5, 6, 7, and 8, believe it, the last week. We talked about those type of things for the course. We looked at the timeline. And then at the end today we put some questions together for the capstone. We're going to visit Newman on January 24th. We did some review. We did the OSI model. We started down here in the bottom. We talked about wireless, wired, and fiber. We didn't spend much time on that. The media. But I did mention bits, and you should be able to convert 10 to 2 to 16. And we can practice that. Practice that on Thursday. All right. Physical layer. How the bits are put on the medium. Then we talked about data link and how that WAN communications primarily work here. And we did a lot of visiting about like just even router to router connections inside a WAN scenario. I always think of it, you know, it has distance. Typically, we think of a WAN that we have distance and some provider, often called a service provider, that allows us to span the distance. Okay, which then develops what we call a wide area network compared to a LAN, a local area network, where the distance is smaller and usually the governance over the whole thing is one entity. Then if we talk about the network, the path, IP addressing, transport layer, how are we going to transport the data? This is going to give us the path. This is how we're going to transport the data using TCP/IP. I believe came out of the 70s. And we have 2 major ways. There's more to it than that, but transmission control protocol and UDP, TCP and UDP. User datagram protocol? I'd have to look that up. We establish a session. So if it's TCP, the session isn't going to end until we have everything we need. How are we going to present the data? And I gave an example, ASCII code to represent text information. And there's other codes. This one's typically used in a PC. And numbers are represented a different way than this. This would be text. Then the application links us into some app. So we did an example. We said a browser running TPPS, so that information then would come down. We come down through, secured, so the data would get encrypted. Then we'd look at the data, we'd split it into segments, we would add a port number, 443, for this. Tie it together with an IP address, where we're going to go, creates, this isn't a perfect definition, but you can think of that as a socket, and that thread is going to run through the machine separate from other things going on. So that all becomes, this whole thing then becomes the data at this layer. So at the network layer, they don't care what's in there. They're just worried about adding this IP address, the source and destination, and then here it becomes a packet. Up here, it's a segment. Here we refer to it as a packet. And then down here, when it gets to the data link layer, we call it a frame. And so this is everything that came from above, and then we add some type of data link addressing. If it's Ethernet, then a MAC address will be put on there. We talked a little bit about frame relay and how that's a packet switch network. And what we were working on is comparing packet switch to circuit switched. Okay. And we'll review that on Thursday. Last page. This is actually where I started. I said we have a router and we want to communicate between the two, so the information has to move from one router to another, going through some service provider, which then gives us this idea of a wide area network. And then I compared it here. These two devices have to communicate, and these two devices have to communicate, and then we use a protocol for that. We use Ethernet and MAC addresses. And then in the big picture, a router is going to route between networks, so then that's the network layer. And we look at the IP addresses to find the best path. If that makes sense. Do we go this way, or do we go this way? Depending on the IP. Make that decision. And that makes sense, right? Because on a router, this would be a different network, this would be a different network, and this would be a different network. To finish up here, we did talk a little bit about Tier 1 providers, and we looked those up. They are the backbone, they're the backbone of communications in the world. There's a limited number of them in the United States, and we talked a little bit about how those came about. But they exchange information, data, and they don't charge each other. And how do they make money? Well, they do. Everybody charges then to get into their network. So if Verizon needs to send information to AT&T, they just send it to each other. They don't charge each other any money to move traffic between their networks. Some of that goes back to how the whole infrastructure was built from around 1910 to the 1980s, when we had a monopoly and it was all under Ma Bell. That's it for today.